This is GACE Practice Test 023, question number 28, in which you are given a function, x cubed plus 1, and you're told this fact right here, which, to be honest, they didn't have to tell you. And so, I mean, you should know this anyway, that that function is 1-to-1 and therefore the inverse exists. But I want to talk to you very quickly about inverses, because what an inverse is, functionally, if I had y equals 2x plus 1, let's say, and I just put some numbers in, x, let me be more specific, f of x equals 2x plus 1, okay? And if I put some values in as inputs, -2, -1, 0, 1, 2 are my favorite inputs. When I put -2 in for that, I get -4 plus 1, which is -3. When I put -1 in, I get 2 times -1 plus 1, which is -1. When I put 0 in, I get a +1. When I put 1 in, I get a 3. And when I put 2 in, I get 5. Okay? This is what f inverse of x is. F inverse of x says, okay, if I had, and I'm just going to choose some values. If I had 5, okay, what function or what input gave me that? So it's basically saying, look at that chart right there. What input into f of x gave me 5? And that answer is 2. Okay. What input into that gave me a 3? The answer is 1. Okay. So it reverses the x's and y's, and it's used, the inverses are used when your inputs are the answers and you have to figure out what the outputs are. Now, to calculate the inputs, okay, what you've got to do, and it's really actually very simple, is you take the original function. If you want to know what function is the inverse of this, you can do it one of two ways. One is you can look at this and see that the input, you took the input, whatever the number was. Then first thing, by order of operation, is you multiply by 2. And then you add 1, and once you do, that's your output. Okay, this is what the function does. Okay, so f inverse, it does exactly the opposite. Okay, you take the input, which is their output, and you move backwards. And in fact, let me just, is it gonna, hold on, let me erase this. Nope, deleted my line. Okay. You take the output as if it were the input. We go backwards and opposite. So the opposite of adding 1 is subtract 1. The opposite of multiply by 2 is divide by 2. And then you get your output that way. Okay, so an inverse function operates exactly the opposite of the original function. And here's how you would calculate that. You take the original function, so f of x equals 2x plus 1, and you just go ahead and put a y in for f of x, just because it's easier to do the math with. And what you do is this. You reverse the x and the y. So you write it as x equals 2y plus 1, and you figure out, how do I get that input out of it? How do I move backwards? And so what you do is isolate y again. So you subtract 1 from both sides and get x minus 1 equals 2y. And then you divide by 2. So y equals the quantity x minus 1 over 2, which is the same thing as 1/2 x minus 1/2. Okay, and you would write it this way. F inverse of x is equal to 1/2 x minus 1/2. Okay, these two functions do exactly the opposite thing. Okay, one, you get input and you get the output. The other takes the first one's output, puts it in, and you get the input. So let me just give you an example. If I used x, f inverse of x. If I said, what gives me an output of -3 in the original function, you can use that to figure it out. you do 1/2 of -3 minus 1/2. Well, that's -3/2 minus 1/2, which is -4/2, which is -2. -2 in the original function is what gave me a -3. Okay, if I put -1 here, okay, so 1/2 times -1 minus 1/2. So that's -1/2 minus 1/2. -1/2, -1/2 again gives you -1. Okay, and you'll start to see that what you're going to find is that the inverse of this function gives you exactly the opposite values, the x and the y flipped. Okay, so looking at this one, algebraically, this is what you would do. If you look at this, y equals x cubed plus 1, and you reverse the x and the y, put the x in the y's place and the y in the x's place, and then you just solve for y again. So -1, x minus 1 is equal to y cubed. Then you would have to know that you can do one of two things, and I'm just going to, at this phase right here, there are two equivalent ways of treating this. One is the inverse of a cube is cube root, and cube root and cube cancel one another. Basically, they're opposites of one another, so you get y equals the cube root of x minus 1. Make sure you understand that the x minus 1 is completely underneath the cube root, which this is how you would write it. So f inverse of x is equal to the cube root of x minus 1. The other thing that you could do, and it just looks different, but it still means exactly the same thing, is taking something to the 1/3 power. That is cube rooting. Square rooting, the exact same thing as taking both sides to the 1/2 power. Okay, so if you took both sides to the 1/2 power, you would have x minus 1 to the 1/3 is equal to, again, those 3 times 1/3 is y to the first power. So another way to write this would be f inverse of x is equal to x minus 1 to the 1/3 power. Just be ready and know that, number one, most calculators, this second one is the easiest way to write that. X minus 1 to the 1/3 power is the easiest way to type it in. Some calculators, you can't type something in cube rooted. You have to do it to the 1/3 power. But this is the more common way to look at that. So that answer is B. Okay, and I do want to talk to you quickly about if you were let's say that you get an inverse question and the algebra is really, really hard and it's not something that you know how to do. If that happens, there's still a way that you can do that in your calculator, and this is what I would advise. You've got the original equation, and that was x cubed plus 1, correct? So I'm going to type that in. And remember, this is something that you use your keyboard for. So you would type in x caret key cubed plus 1. Okay. Note that the very first one is a red function. Okay. So then I would go to the next function, and I would do new. I'm going to choose a different color so that I'm real clear on which one is the original and which one is not. And I'm going to go 1 divided by, anytime there's more than one thing in a numerator or a denominator, you must enclose it in parentheses. So this is selection A, okay, and it's yellow, and there it is. I'm going to do a new one and do x minus 1 cubed. Now I'm going to look and see. I'm not sure if there's a cube root. Sorry, cube root is what I meant to say. I'm not seeing cube root. Root, as it's written on this calculator, is we're going to have to explore that. I'm not exactly sure how to use that. And this is where doing that, I think there's a way to do it, and I'll play with it, and I'll let you know. But here's where, if you see the cube root of x minus 1, it is so much easier just to type it in like this. Let's put the x in there. First of all, I have to put it in parentheses because there's more than one thing underneath the cube root. Then I do to the power of, remember that cube root is the same thing as the power of 1/3, and fractions always go in parentheses. And this is number B. I'm going to make it that drab green. And there we go. I'm going to do C. C is cube root of, it's only cube rooting x. So I'm going to go x to the power of, fractions always go in parentheses. It's still not typing. Hold on. X to the power of, fractions go in parentheses. X to the power of 1/3 minus 1. I'm going to choose a different color. I think there's a bright green in here that I can select. Oh, what just happened? All right, here it is. X to the power of 1/3 minus 1. Let me just get out of this just a second. Okay, and I'm going to click OK to that. And then I'm going to do the fourth one, which you cannot see right now, but, well, here, it's 1 over the cube root of x minus 1. So I'm going to get in here. 1 divided by, remember, more than one thing gets parentheses, and that's x minus 1 to the power of 1/3. 1/3 is in parentheses, and that's a bright blue color. Okay, so I'm looking at all of these. Remember, here's the big thing to remember, and that is that when you're looking at the graph, okay, an inverse is going to be reflected, a reflection across the line y equals x. This is clearly not a reflection of across the line y equals x. It would look symmetric on both sides. So it's not A. I'm going to unclick A and now check B and look at the graph here. Notice the line y equals x goes right here, and it splits these two right down the middle, which is how you would know it's B. But let's just look at the other two just for the sake of looking. It looks similar, but it is not symmetric. There's a little bump that goes the wrong way here, so it's not C. And on D, I'm going to look at that graph. Again, not symmetric around the line y equals x. So you know just by looking at the graph, if you couldn't figure out any other way, that yes, those are inverses of one another. And so again, the answer would have been B.